In the last section, we started introducing the every and some helpers. And we did that by creating this array of computers. Each computer had a certain amount of RAM, and then we said that we have a program that requires at least 16 gigabytes of RAM. So we wanted to figure out, rather than finding just a list of the computers that could and could not run the program, I wanted to get just a Boolean value and say, can all of them run the program, or at least can some of them run the program? And so we first did that with the for loop, and there was a decent amount of logic in there, and we had to fiddle around with the defaults of these Booleans, try to figure out what's going on. At the very end, we eventually ended up with a refactored snippet of code down here where we use the every helper. So with the every helper, we have an iterator function, and inside the iterator, we have to return a Boolean value. If every single element returns true out of this expression right here, the every helper will return true. But if any element returns false, then the whole expression will return false as well. And so we saw that with the diagram over here of every. So we had 24, it returned true, 32 returned true, 4 returned false, however. And then at the very end of the day, out of every element, we could kind of imagine that internally it's doing an and looking at all these different return values to eventually produce a single result of false in this case. So we could have easily made this thing pass by saying, does every computer have at least greater than 2 gigabytes of RAM? And now you can see, okay, sure enough, yes, every computer has at least greater than 2 gigabytes of RAM. But we really want to deal with 16 here. So again, I know I'm really harping on this. I know you're probably getting tired of me telling it or saying it, but up here, kind of, unclear logic. We've got a hefty number of lines. It looks about 11 lines of code or so. Whereas down here with the every helper, this is 3 lines of code, and the benefit to this is any engineer who looks at this in the future, they're going to see that keyword right there. They're going to see the word every, and they're going to say, okay, every, I've got a reasonable idea of what the every helper does, and so I've got a reasonable idea of what this function or what this expression right here returns. It's probably going to return a true Boolean value. So again, I'm just a huge proponent of using these array helpers over using for loops or anything like that. So let's continue on now and wrap up this example by implementing our sum helper as well. So the sum helper, let's check out a diagram, works very much like the every helper. And again, that's why we're covering both these at the same time. So with every computer, we pass in the computer into an iterator function, and it will return a Boolean value. So up here in the 16 case, we return true. 4 is less than, 16, I meant to say 24 gigabytes of RAM, just to be really clear. When we have 4 gigabytes of RAM, that's going to return false, and then 32 is going to return true because it's greater than the 16 gigabytes of RAM we need. Now, the difference between every and sum, with every, we look at all the values that get returned, and we kind of imagine that there's an and operator between each one. But with sum, which we're looking at right now, there's an or operator between any value. So with sum, we're saying, do any records in this array satisfy this criteria? Do any records have greater than 16 gigabytes of RAM? So yep, at least one does over here. And we've got the and operator is eventually going to return true. So everything else could return false, but at least one record returned true. So with the sum helper, we would expect to get true out of it. So let's put this example together. In practice, the code is going to look nearly identical to the every helper. So we'll put in our iterator function, and then we'll return computer.ram greater than 16. And in this case, again, at least one computer, yep, does have greater than 16 gigabytes of RAM, so we get a result of true from this. Again, do not forget to put this return keyword in here. Just the most common problem. I see it all the time. I even make that mistake myself. If you forget the return keyword, the function is going to return undefined, and your sum helper is going to think, oh, okay, well, he's returning undefined from every iteration through the array, so I guess no computers match the criteria he's looking for. So let's not forget that return keyword in there. Okay, so I know that between this video and the last one, been a little bit long. Let's continue in the next section with one more example of every and sum, and then we'll work into some exercises after that. So I'll catch you in the next section.